It really feels like the world of large language models is moving at, well, warp speed, doesn't it?
Absolutely. Every time you turn around, there's a new model, a new technique.
Yeah. Claiming to be the best, pushing boundaries. And for, you know, someone listening who wants to stay informed but maybe doesn't have all day to sift through papers,
Uh,
it feels overwhelming.
like trying to catch smoke, yeah.
Exactly. That's where we come in.
Right. We're here to cut through that noise, dive into what really matters. And today, we've got something pretty fascinating. It's research from Microsoft and Tsinghua University.
Okay.
They're calling it arena learning. And it's this really innovative way to figure out how good these models are, and maybe more excitingly, how to make them better continuously.
Arena learning.
Yeah.
Okay, that sounds intriguing, like gladiators. But for AI, what's the core idea?
Something like that. Think about the LMSYS chatbot arena, where people chat anonymously with AIs and vote.
Oh, yeah, I've seen those leaderboards.
Yeah.
Good way to get a feel for which ones are, well, better conversationalists.
Exactly. Arena learning takes that basic idea, the head-to-head comparison, but does it internally using AI itself as the judge.
Okay, let's unpack that. So instead of relying purely on people, which I imagine is slow and expensive,
Very.
you use AI to simulate those battles and pick a winner.
That's the gist of it. They have powerful AI models acting as judges. They watch these simulated chats, evaluate them based on certain criteria, and decide who performed better. And this whole process, according to the researchers, kicks off what they call a data flywheel.
A data flywheel, I like the sound of that. Like it builds momentum. How does that actually improve the AI?
So the results from these AI judge battles feed back into the system. They're used to refine and improve a specific LLM, the one they're targeting.
Okay.
By seeing exactly where that target model fails compared to others in these simulations, the system can generate new training data specifically to fix those weaknesses.
Yeah.
Then the model gets updated, gets thrown back into the arena, and the cycle repeats. Evaluation, learning, improvement, evaluation.
That's genuinely clever. So for this deep dive, we're really digging into the research behind this arena learning, specifically how they used it for their Wizard LM models.
Precisely. We're looking at the paper introducing the concept and how they applied it to build Wizard LM and Wizard LM2.
Got it.
We'll explore how it tackles the big challenge of evaluating LLMs, how the system actually works, why it's a big deal, and, what it might mean going forward. The mission today is basically to give you a clear handle on this approach without getting totally bogged down in the jargon.
Sounds perfect. So let's start with that core problem arena learning addresses.
Right.
We know LLMs are advancing fast, but why is it so hard to actually measure which ones are truly better?
Yeah, that's a key point. As these models get more capable, our traditional ways of testing AI, like standardized benchmarks, they start to fall short.
How so?
Well, they might not capture how well a model handles a natural, flowing conversation, or how accurately it follows, say, complex multi-step instructions in a real-world kind of way.
Right, like a multiple choice test on grammar doesn't tell you if a chatbot can actually help you plan a trip or debug some code.
Exactly. It's like judging a chef on a written test, not the taste of their food. That's why things like the LMSYS chatbot arena emerged.
The human element.
Right, pitting models against each other anonymously, letting real people vote. It gives a more dynamic, realistic assessment, and they use that ELO rating system, like in chess, to rank them based on these direct comparisons.
Yeah, I've definitely seen those ELO rankings. They seem pretty influential. But you mentioned limitations earlier.
Yes, hugely insightful, but relying only on human evaluation at that scale. It has drawbacks, it's time-consuming, it costs money to manage.
Takes a lot of people hours.
It does. And that limits how often you can get reliable rankings. It also limits how many different models can realistically even participate enough to get a stable score.
Makes sense. If there are thousands of models out there, you can't have humans chat extensively with every single one.
Exactly. Some models might just not get enough human interaction data to be judged fairly or for that data to be useful for improvement. The researchers saw this bottleneck. They needed something faster, more scalable, but that still captured that comparative evaluation spirit.
Okay, so this is the gap arena learning aims to fill.
Yeah.
Simulating those battles offline with AI judges. How does that simulation actually work?
So the main goal, remember, is that efficient data flywheel for continuous improvement after the initial training, post-training.
Right.
Instead of waiting for human votes, they use a very capable LLM as the judge.
An AI umpire. Who gets at the job?
Well, in their research, they use Llama 3 70B chat. a very strong model itself.
Okay.
They basically show it the conversation, the prompt, and then the two different responses from the models that are battling.
And then the judge model.
Yeah.
Judges, what's it looking for?
They give it specific instructions. Look at coherence. Does it make sense? Factual accuracy. Is it correct? Context awareness. Does it follow the conversation? And just overall quality and helpfulness.
So pretty comprehensive criteria.
Yeah. Based on those, the judge model gives scores and, crucially, explains why it thought one response was better than the other.
That reasoning part sounds important. But what about bias? Could the AI judge, have his own hidden preferences, favor certain styles?
That's a really valid concern. They thought about that. They use a two-game setup.
2 games.
Yeah. For each prompt and pair of responses, they run the evaluation twice. First time, maybe Model A's response is shown first, Model B second.
Okay.
Second time, they swap the order. Model B first, Model A second. This helps cancel out any bias the judge might have just based on the position or order it sees the responses in.
Ah, that's clever. Controls for that potential ordering effect. Okay, so we have the AI judge, the 2-game setup. Where do these battles happen? What's the arena itself?
Good question. It's not a physical place, obviously. They developed something called Wizard Arena.
Wizard Arena.
It's a carefully prepared, offline set of test questions or instructions. And it's not just a random grab bag. It's designed very specifically to have broad topic diversity and a high level of complexity.
Okay, tell me more about Wizard Arena. How do they build this test set to make sure it's actually, a good measuring stick?
They broke it down into two main parts. First, the diverse subset. The goal here was coverage hitting a wide range of subjects, different conversational styles.
How do they ensure that diversity?
They used text clustering. Basically, they took a large set of instructions, turned them into numerical representations using an embedding model, very large, I think.
Which captures the meaning.
Exactly. Then they grouped similar instructions together using algorithms and picked representative samples from each cluster. So not just picking randomly, but ensuring representation across different types of prompts.
Okay, so that covers the breadth. What about the complexity you mentioned?
That's the second part, the hard subset. For this, they specifically wanted instructions that would really push the LLMs, test their reasoning, handle ambiguity, that sort of thing.
And how do they know which ones were hard? Gut feeling.
Nope, more AI. They used another powerful model, GPT-4 1106 Preview, to predict the difficulty of instructions.
Wow, using GPT-4 to figure out what's hard for other AIs.
Pretty meta, right? They had it rate the difficulty, and then they selected the instructions that scored highest to form this hard subset.
Okay.
And Wizard Arena combines both the diverse and the hard subsets into the offline mix Wizard Arena. This also includes multi-turn dialogues, making it feel more like real conversations.
That sounds really robust. A mix of diverse, hard, multi-turn prompts. So the big question, how well does this AI-judged Wizard Arena actually line up with the human judgments from the online LMSYS arena?
This is where it gets really compelling. They found a remarkably high consistency. The ELO rankings generated by Wizard Arena matched the rankings from the live human-judged LMSYS Chatbot arena with an average agreement of 98.79%.
Wow, nearly 99%. That's incredible.
It really is. Significantly higher alignment than they found with other existing benchmarks like Arena Hard or MT Bench.
So the AI judges are doing a surprisingly good job of essentially mimicking human preferences at scale.
Right.
This isn't just cool tech. It means we have a faster way to see which models are genuinely better at tasks people care about.
Precisely. It validates the whole approach of using AI judges. And, maybe just as importantly, they calculated that using Wizard Arena was about 40 times faster than relying on the human evaluation process.
40 times.
Yeah.
40.
Yeah.
So it's reliable and massively more efficient. That feels like a genuine step change in how we can evaluate these things.
It really does, and that combination of reliability and efficiency is what powers the data flywheel for actually improving the models.
Okay, right, the flywheel. We've got the reliable feedback loop now. Let's dive into how Arena Learning uses those battle results to make the target LLM better. How does that post-training flywheel actually spin?
So it starts with the model you want to improve, in their case, Wizard LM. This model gets put into simulated battles against a whole roster of other strong state-of-the-art
The
models.
sparring partners.
Exactly. Using a big set of instructions, it's like throwing your trainee into the ring with various experienced fighters to see where the weaknesses are.
Makes sense. Find the gaps.
Then, after the battles, the AI judge doesn't just say Model A1. It highlights the specific cases where the target model's response was judged worse than the competitors.
Okay, so it pinpoints the exact failures.
Yes, and that's the crucial input for the next step. generating new training data. They take the winning response from the competitor in those specific instances where the target model failed
Ah,
and use that winning response as the target, the correct answer for the model to learn from in the next round of training. It's learning directly from its competitors' successes on its own failures.
that's super smart. It's like targeted coaching. You messed up this reasoning question. Here's how the champ did it. Learn this.
Exactly. And this new targeted training data is used to update the model. They mention using a few techniques: SFT, supervised fine-tuning,
But showing it the right answers.
right, and DPO, direct preference optimization.
Teaching it to prefer the good stuff.
Yeah. And PPO, proximal policy optimization, which is more about learning through trial and error, but safely. Basically, different ways to teach the AI using the feedback from the arena.
So it gets trained on its losses. Then what? Back in the ring.
Absolutely. The updated model goes right back into the wizard arena for more battles, maybe against the same rivals, maybe new ones, battle, identify weaknesses via the judge, generate targeted data, retrain, repeat. That's the flywheel.
Can you give us some specifics from the paper? How did this work out for Wizard LMA? Did they see real gains?
They did. They ran experiments on a 7 billion parameter version and a larger 8 by 22 billion parameter one. They went through 3 main iterations of this cycle: I1, I2, I3.
Iteration 1, 2, 3.
Right. And in each one, they used specific data sets and pitted their models against a changing lineup of strong competitors, like different GPT versions, Claude models, etc., as detailed in their tables.
And did the ELO scores go up? Did they get measurably better in the arena?
Significantly. On their main benchmark, Wizard Arena Mix, the 7B model gained over 400 ELO points across the 3 iterations. The big 8 by 22B model gained even more, 460 points. Huge jumps.
Wow, that's substantial improvement just from this iterative process.
And importantly, they also saw scores improve on other, more general benchmarks like MT Bench. So the gains weren't just confined to their own arena setup.
That's key. It translates.
Exactly. And they also tracked win rates against top models like GPT-4o. Those win rates consistently climbed through the iterations. Real progress.
What about how they chose the data? Did they learn equally from all losses, or some more important? The paper mentioned a pair judge method.
Right. They looked into that data selection strategy. They found the pair judge approach was really effective. It specifically targets instructions where the AI judge found a large performance gap where the base model really bombed compared to the winner.
So focus on the big mistakes, not just any loss.
Precisely. By concentrating the training effort on those clear failures, they got more bang for their buck, data-wise. Better results than just using random losing examples or other methods. It's like prioritizing your biggest weaknesses.
Quality over quantity again. Focus on the most instructive failures.
Exactly. And related to that, they explored data size. They found that because this selection was so targeted, based on battle outcomes, they could get significant improvements even without using massive amounts of new training data in each cycle. They showed this by varying a threshold, K, for selecting data.
So smart data selection means you don't need a fire hose of data, just the right data.
It seems so. Quality targeted data is key. They also noted the difficulty of the selected training data tended to increase over the iterations.
Makes sense. As the model gets better, it needs harder challenges.
Right, and they did ablation studies too. Looked at, say, the number of models they've battled against.
Did that matter? More opponents better.
It did. Battling against a diverse set of strong models led to better overall improvement than just battling one or two. Like, training against different fighting styles makes you a better all-around fighter.
Get exposed to more tricks, more approaches.
Exactly. And maybe unsurprisingly, they also found that learning from more advanced models yielded bigger gains. When Wizard LM battled and learned from something like GPT-4o, the improvements were greater. Learn from the best.
Stands to reason.
Yeah.
So you mentioned the training data getting harder. Did the type of data change over the iterations too?
Yes, and this was really interesting. They analyzed the categories of instructions where Wizard LM was losing early on.
Okay.
And they saw that in later iterations, the training data automatically selected by the process started to focus more heavily on categories like mathematics, reasoning, and coding areas where LLMs often struggle initially.
So the flywheel wasn't just improving the model generally, it was actively identifying and targeting the model's specific weak spots category-wise.
That's exactly what it suggests. The system was learning what the model needed to learn next, based purely on the battle outcomes. It was adapting the curriculum automatically to patch vulnerabilities.
That's That's really sophisticated. The whole system learns and adapts.
It really is. It shows the power of this closed-loop AI-driven approach for evaluation and continuous improvement.
Okay, let's bring it all together. For someone listening, what are the absolute key takeaways from this deep dive into arena learning?
I'd say the big one is this. Arena learning is a fast, cost-effective, and crucially reliable way to both evaluate LLMs and make them better continuously.
Faster, cheaper, reliable evaluation and improvement.
Exactly. By using AI judges to simulate those human chatbot arena battles offline, it gets around the time and cost bottlenecks of pure human evaluation, but it still lines up incredibly well with human preferences. That 98.79% consistency is huge.
So for our listener trying to track AI progress, this matters because it shows a powerful new engine for driving that progress, right? A way to make models better, faster.
Precisely. It gives us insight into how development is accelerating. This kind of system lets researchers rapidly find model weaknesses and automatically generate the right data to fix them. It fuels that continuous improvement cycle, the data flywheel.
It really paints a picture of a more dynamic, adaptive development process than just throwing more data at the problem. It's about intelligent refinement.
Well put. And it leads to a final thought, maybe something for you, the listener, to chew on. Given how effective this arena learning seems to be, how might this kind of automated continuous improvement loop speed up the arrival of even more capable, maybe more specialized AI assistants in the future?
Mm.
If you can automate the process of getting better and better based on simulated real-world interactions, what does that mean for how quickly we might see AI that can help us in much more personalized, complex ways? What are the implications for our daily interactions with this tech?
That's a really potent question.
Yeah.
If the improvement cycle itself gets automated and accelerated,
Yeah.
yeah, it makes you wonder about the pace of change ahead. Might be time to finally look up that Wizard LM project, maybe brush up on ELO ratings too. Thanks so much for walking through this.
My pleasure. It's fascinating stuff, always evolving.